Hi, here's the next in our series of live streams, and on this one we're going to be concentrating on functions from C3 and parametrics from C4. So we start off with looking at the C3 functions page, and there's quite a lot of facts you need to know about functions. Okay, so you need to be able to simplify rational expressions using factorization and other methods. Domain and range functions, inverse function, use of domain equals range of the inverse and vice versa. You need to be able to do composite functions, modulus functions, and transformations that are used in C1, plus all these ones which come up in C3, especially the modulus ones here. So there's quite a lot you have to know for the functions stuff, lots of little bits and pieces. You must make sure you know all of this and all of this off by heart. Okay, it's no good sort of knowing it and hoping you'll be okay. You need to know every single bit of this. So let's have a look at our first question. Let's just see if I can zoom it in so it all fits on one page. Just a little bit more. There we go. So just in case this has come out a bit small, the function here is f of x goes to 3 minus 2x over x minus 5. Sorry, that x there seems to have come as part of the function. It's x is a member of the reals. X is not equal to 5, and you've got a graph of g of x. The numbers are 9, 6, minus 1, 2, 4, and 8 there, and they're listed again over here. So I'm going to give you, it's a long question, this one actually. I'm going to give you about, I'm going to give you more than I've got here on my, oh no, I've got a 10-minute one. That should be a good starting point because it's a long question. So have a go at this. Give you 10 minutes to go, have a go at that, and then I'll go through that question because it covers most of the areas of functions. Right, here we go. That's plenty of time to have at least had a good go at that. The first part of the question is over here, is to find f minus 1 of x. So what we do is we let y equal f of x and then rearrange to make x a subject, which I'm sure you all remember. So we can do this by timesing both sides by x minus 5. So we get y times x minus 5 equals 3 minus 2x. Multiply out the brackets, yx minus 5y equals 3 minus 2x. Get all the x's on one side, all the y's on the other side. So I'm going to jump that through a bit. That's going to be plus 2x, 3 plus 5y. Factorise, get x on its own, so get y plus 2 equals 3 plus 5y. So therefore x will equal 3 plus 5y over y plus 2. Remember to write the function out properly. Inverse function of x will therefore be 3 plus 5x over x plus 2. B, write down the range of g. So our function g is here, and the range is given by the y values it covers, okay, what it maps onto. So it goes from minus 9 all the way to 4. As we know, this is less than or equal to, and this is less than or equal to, the range is also going to be less than or equal to. So we have minus 9 is less than or equal to g of x, or y would be okay as an answer, is less than or equal to 4. Next we want to find g of 2. Well, if we put 2 into g, we get 0 out. And then we put 0 into g again, we get minus 6 out. So g of 2 equals g of 0, which equals minus 6. So okay, so you just think about it, you put 2 in, look for where it cuts the g function, where it cuts it straight away. Then you've got 0, and then you put 0 in, see where that cuts the g function, and that's at minus 6. Now we want to find f g of 8. Well, g of 8 is equal to 4. So that's equal to f of 4. And we know to find f of 4, we're just going to put it into here. So let's find f of 4. So f of 4 will equal 3 minus 2 times 4 over 4 minus 5. So that's 3 minus 8, which is minus 5, divided by minus 1. That will give us 5. Okay, for part E, on separate diagrams, sketch the graph equation y equals mod g of x. So let me just get some axes. Just looking at this one. Just move it there. So I've got myself some axes. Now, let's just rub out all that working. So I can see g. So g is this graph here. Now, the modulus of that means you make everything positive. So this is already positive, this bit. Here, this bit's already positive, so we just got to make this bit here positive. So effectively, you might like to think of it as just a reflection of that bit in the x-axis. So it's not going to go through 4, it's going to go through a bit further up, it's going to go through 6. So let's just draw that. So we've got this point at 2, then we're going to cross there, and let's make sure, oops, undo that. Let's just make sure that bit crosses here at 6, and therefore this is still going to be at 4. So this is y equals mod g of x. Now let's just do the next one. So get myself another pair of axes. Move it a bit. There we go. And we want to find inverse function of g of x. Now we know that g of x is something like this, followed by that. Now, what we also should know is that the g of x is a reflection of the line y equals x. So therefore, this, where this is minus 6 here, it will be minus 6 over here. And where this is 2 here, it will be 2 over here. So therefore, we're going to get that going like that. Minus 6, 2, and then this is going to go off over here, and you notice these should be mirror images in the line y equals x. So but this is good enough for our answer. We don't need to actually draw the rest. That would be perfectly fine, showing that it cuts at -6 and at 2 and that it goes off. So this is y equals g minus 1 of x. State the domain of the inverse function minus g to the inverse g of x. All right, so the domain of the inverse function is actually equal to the range of the original function. So the range of the original function is minus 9 to 4. So the domain, okay, the domain will also be minus 9 is less than or equal to x is less than or equal to 4 for g minus 1. Okay, so remember the range of g is equal to the domain of inverse g, and consequently the range of inverse g will also equal to the domain of g. Right, time to now look at some C4. We've already spent, what's that, a good 20 minutes on that. We're going to do some C4, look at the parametrics, and we'll jump straight in. One of the key things for parametrics is knowing your trig equations and how they work together to be cancelled out and leave you just x and y. So here's a good question to illustrate that. The only a 5 marker, I'll give you 4 minutes to have a go at that. Okay, right. Quite a tricky one probably to do in the 5 minutes, especially, well, I gave you 4, didn't I? But let's see how we get along with this. I'm going to just make the question a bit smaller so that I can just create a bit more space to work in. So I'm going to start at the top here. So we know that we want to show that x plus y equals this. So let's write out what x plus y equals. It should be our starting point. So x plus y from the original thing is going to be 4 cos t plus pi by 6 plus 2 sine t. Actually, I'm going to give myself more space because I'm now going to expand this bit here and see what I get from that. So I'm going to get 4 cos t cos pi by 6 minus 4 sine t sine pi by 6 plus 2 sine t. Cos of pi by 6, I mean, how I remember them, I don't actually, well, I probably actually do remember them, but I think I can sort of, cos of pi by 6 is the first one I come across. It would be the big one. I just remember they're going to be root 3 over 2, root 2 over 2 and a half for the coses and sines. I've just got to remember the order. Now cos goes that way, big to small. That's how I remember my orders. So therefore I'm going to get x plus y equals 4 times cos of pi by 6, which is going to be root 3 over 2, so it's going to be 2 root 3, 4 times root 3 over 2 cos t. And we're going to see this might have caused you a few problems because there's a typo here. That's why I'm pausing, because I'm just checking my working, and my working's correct, and I know that there's nothing wrong with it. Okay, I already can see there's a problem coming up. Times a half plus 2 sine t. And I know I've not made a mistake because actually all of this is coming out nicely, and I get 2 root 3 cos t minus 2 sine t plus 2 sine t, and those two are going to cancel. Okay, so actually, sorry about that, this should have said x plus y equals 2 root 3 cos t. Show that, and that is what x plus y equals, 2 root 3 cos t. Okay. Next, we want to show that the Cartesian equation of C is equal to x plus y squared plus ay squared equals b. So let's work out what x plus y squared is. Okay, x plus y all squared is equal to 2 times root 3 squared. It's going to be 4 times 3, so it's going to be 12 cos t. So we get 12 cos t, and we want an ay squared, okay, in there to help us get a constant value. So what we do is we're going to realize that x plus y squared over 12 will equal cos t. Now if I actually work out y squared, that's going to give me 4 sine t, and I've just made a mistake here, haven't I? I need to put a cos squared there and a cos squared there, and then I need to put a sine squared in there. So y squared over 4 equals sine squared t, and this is a very common technique to get something involving equal to sine squared t and something equal to cos squared t, because cos squared plus sine squared equals 1. So we get therefore x plus y squared over 12 plus y squared over 4 equals cos squared t plus sine squared t, which equals 1. Now we want to get x plus y squared plus ay squared equals b, so we need to times that by 12. So x plus y squared plus 12 times this is going to be 3y squared will equal 12. because that's equal to 1, so 1 times 12 is 12. And that gets us our final answer. So sorry about the typo in there. That wasn't me, that was the database from Edexcel giving that typo, but at least I wonder if actually you managed to spot it and just carry on. Now, let's have a look at question 2. Notice that the idea we did of cancelling out. Let's have a look at question 2, which has got a bit of differentiation involved in this question. So it's a bit of a longer question. I'm going to give you 9 minutes to have a go at this and see how you get on. Right, here we go. Let's have a look at this question here. So, quite a standard parametric question where you've got to find equation of a tangent, or it could be equation of a normal normally as well, and you just differentiate with respect to x and with respect to t, x and y and use the chain rule to find out. And first of all, we've got to find out where they cross the x-axis. So we know it crosses x-axis here and here and here, and that is when y equals 0. So we know that y equals 0, so this implies that 0 will equal t cubed minus 9t. So 0 equals t. So I'm just going to give myself a bit more, not that much space, a bit more space. So t squared minus 9, which is t open brackets t minus 3 t plus 3. So t can equal 0, minus 3, or 3. So when t equals 3, x will equal 9 plus 2 times 3, which is 15. So that's point B. And when t equals minus 3, x will equal 9 minus 6, which equals 3. So therefore, A is going to be the point 3, 0. And obviously t equals 0 gives you 0 squared plus 0, which gives the x value 0, which is the third point there where it crosses the axes. So we now found A and we found the point B. Now I want to show the equation of tangent to the curve at B is equal to 9x minus 4y minus 135. To do that, we need to find dy by dx, the gradient at that point. But first, we need to find dx by dt, which is equal to 2t plus 2, differentiating this, and dy by dt, which is equal to this differentiated, which is 3t squared minus 9. So this implies that dy by dx will equal that divided by that. So it's 3t squared minus 9 over 2t plus 2. Just in case you didn't know this chain rule equals that times by that. And you can see that it doesn't really cancel, but it helps you remember it. Okay, these are not fractions, they are derivatives. So we know that they don't cancel, but it just helps people remember it. Anyway, we're at the point B, so we've got to put in those values to find out what, and at point B, t was equal to 3, so put that in. So be careful, easy mistake here, I nearly did it myself, is to put 15 in. So you've got 3 times 9 minus 9 over 2 times 3 plus 2. So that will give us what? 27 minus 9 is 18 over 6, 8, 18 over 8, which is going to cancel down to 9 over 4. So we've got our gradient. So we know that if I always use y minus y1 equals mx minus x1. If you use y equals mx plus c, it makes you look a bit Mickey Mouse. I suggest you use this formula. It makes you look a bit more like a real mathematician. The y value is 0 at b, m is 9 over 4, x, and the value at b was 15. I now always multiply by 4 at this point, so get 4y, and then I can multiply out the brackets 9x, and then 9 times 15, so I've got 9 times 10 is 90, plus 45 is 135, and it's all looking good. So therefore we bring the 4y to this side, we get 9x minus 4y minus 135 equals 0. Now the tangent to the curve at B cuts the curve again at the point x. So let's just look at that. So our tangent, see if I can get a tangent going. There we go. Cuts the curve again here. Okay, so we're looking for a value where so the x value is going to be less than 15 and bigger than 3. So that gives us a guidelines looking at our graph. What we need to do, and you always need to do it this way, is you take your x value of t and replace x here. Okay. So take the x value there and replace our x value here, and take our y value from here and put it in here, and then solve for t. And then once we've got t, we can find our x and y values. So we know that we've got 9 open brackets x t squared plus 2t minus 4t cubed minus 9t minus 135 equals 0. So let's multiply that out. We're going to get 9t squared plus 18t minus 4t cubed plus another, what's that, 4 times 9 is going to be 36t plus 4 times 135. No, I don't need 4 times 135, being stupid there, because it's not in the brackets. Minus 135 equals 0. So I'm going to, if I change the signs of everything, I'll get 4t cubed, I like my first thing to be positive, minus 9t squared. And what have I got? I've got 36, so that's 46, so it's going to be 54t plus 135. Changing the sign of everything, and that's not going to be a plus, sorry, because I changed the sign of everything, didn't I? So it's a minus equals 0. So we need to try and factorize this out, and it's not easy to factorize, I'll give you that. So how would you do that? You would try and look at factors 135 and see what could go into that, and actually 9 and 15 seem to go into that. Let's just try putting, how would we factorize this easily? See, I know I've got the answer ahead. I think I would try looking at numbers that go into 135. Let's look at what goes into 135. We've got 5 goes into that, obviously, so it's going to go 2. And then there's going to be 3 left over. That's going to give me 27. So I've got 3, 3, and 3 going to 135 and 1. First of all, we're going to use the factor theorem. So I'm going to always try 1 and minus 1 in it. And if we try 1 and minus 1, we can see quite rapidly it's not going to work. It's not going to give us 0. So let's try 3. And minus 3, that's our next nearest factors. We've got 3, and then we've got 5, then we've got 15, and we've got 9. We can try all of those, but I'm going to always try the small ones first. So we put 3 into here. We're going to get 4 times 27 minus 9 times another 9. So it's going to give me 4 times 27 minus another 9 times 9. So it's minus another 27 minus 54 times 3. And that's going to give me 0. So that works. So therefore t minus 3 must be a factor. Okay, t minus 3 must be a factor. And therefore we can then do division. Well, you can do this in lots of ways. Lots of you I know prefer division. To find out what's left. So t into that goes 4t squared. Times back 4t squared minus 12, 4t cubed minus 12t squared. Subtract that, that leaves me 3t squared minus 54t plus 135. And t into 3t squared gives me plus 3t. So 3t squared, take away, I'll put that back in there. 3t to minus, it's going to be minus 9t here. Take that away. So that's going to be 9 away from 54 is going to give me 45t plus 135. And t into 45t will give me 45. 45t, hopefully it's going to come to 0. 45 times 3 gives me 135. So that cancels out to 0. So that shows it as a factor. So I can now write that t minus 3 open brackets 4t squared plus 3t plus 45 equals 0. And now I can factorise this. And I want numbers at times together to give me 45 combined together with 4. That can give me 3t. So 15 times 3, 4 times 3 is 12. That's going to work. So I'm going to put my 3 over here, my 15 over here, my 4t here. And I've got a mistake somewhere. That's a minus there, isn't it? Sorry. Now, the reason why I know there's a mistake is because I need to change the signs here to get 12. So that's a minus, therefore that's a minus, therefore that's a minus. Okay, so how to spot errors on the fly, get a feel for what's going wrong. The numbers were working nicely, except that was the wrong sign. And I did remember that I had a minus 135 here. So what do I want? I want this to be positive, and I want that to be negative. So therefore t equals 3 or minus 3, no, 3, because that's exactly the same thing there. Or I'm going to get t is equal to minus 15 over 4. And as I think t equals 3 was where we were at b, where is it? T was where we were at b. Yes, it was. It was t equals 3. We're going to use t equals minus 15 over 4 and put that in for x and y back here. Sorry, as I've gone down the page, I've gotten a lot bigger. So I've got to put it into find my x coordinate using t squared plus 2t, and my y coordinate using t cubed minus 9t. So t squared. So I've got t squared minus 2t for x, and I've got my y value is t cubed minus 9t. So I need to work out x will equal minus 15 over 4 squared minus 2 times minus 15 over 4. And I could work that as to be what, 225 over 16 minus 30 over 4. So times that by another 4, it's going to give me 120 over 16. That gives me 1 over 5 over 16. And my y value is going to give me, sorry, I was just checking my stream, minus 15 over 4 cubed minus 9 times minus 15 over 4. Fortunately, I can't remember what 15 over 4 15 cubed is. So 15 to the power of 3 is 3375. 3375 over 64 minus 9 is 90, it's 135, it's plus 135 over 4. I'm just going to cheat and just use a calculator. So 3375. So I've got answer divide by 64 plus 135 divide by 4. That gives me 86 point something or other. And cheekily, an easy way, it's obviously going to be a fraction involving 64. So if I actually times my answer by 64, just delete there, so I gotta go backspace with backspace, 64. I get 5535 as my other value, and this is going to be all, oh, that was a negative there, wasn't it? So I've made a mistake. That was a negative there, so that won't be that. So fortunately my calculator allows me to go back and rectify all that. If I go put a minus sign there, everything else changes. And I get minus 1, 2, 1 and 5 over 64. Okay, so my coordinates are 105 over 16, comma, minus 1215 over 64. Not very nice numbers. You could give them as decimals. The question does not ask for exact values. I just gave you an exercise on how to do fractions, but it could be possible that they want for exact values in the exam that you do, but there it didn't. So actually you could have just bunged it all into the calculator and got decimals out if you wanted. I just showed you a quick way how to use your calculator to get help you with the fractions as well. Okay, what you'll notice is I've put some further questions in here. So you've got parametrics. These are standard A-level questions, and these are the international A-level questions. Okay, so these are international. Some people think they're slightly harder. Okay, the second of the two questions we did was an international A-level, and you can see whether it came a little bit harder with the fact that it asked you to do that nasty factorization of a cubic, which doesn't often happen because that takes more time. If we go back to the C3 and the functions, you'll see I've put some further functions questions in there. I haven't bothered with international questions for the C3. I think it's much better to tax your C4 knowledge and make sure you can get good marks on the C4 to guarantee A stars if you're aiming for A stars. There you go. I hope to do another stream tomorrow. Probably it's going to be in the afternoon, not the evening though. I'll send you an email. Thank you and good evening.